Hello, thank you for watching this video. So in this video we're doing question 8 of May, June 2022, question paper mathematics paper 1. And these are derivatives, calculus. So I'll start at 8.1. So 8.1 reads as follows. Determine f prime at x from first principles if it is given that f of x is equal to negative x squared. So they are asking you to determine the derivative of f if you are given that f is equal to negative x squared using first principles. What do they mean when they say first principle? Which means use the definition, use the derivative definition to find the derivative of f. So you know that the derivative definition is the derivative of function is obtained. The derivative of our function f is obtained by taking the limit as h goes to 0 of f at x plus h minus f of x all over h. You take the limit as h goes to 0 of h of x plus h minus f of x all over h. Take the limit of this thing here. So you know what your f of x is. Your f of x is equal to negative x squared. But you don't know what your f at x plus h is. So you need to go and find what f at x plus h is. So how do you do this? Okay. F at x plus h is equal to, so negative. We see your x here, put your x plus h. X plus h squared is equal to negative. Then you expand this. So when you expand this, you have x squared plus 2hx plus h squared, right? So you say, okay, f prime at x, f at x plus h is equal to negative x squared minus 2hx minus h squared. That's what we do. So this is your f at x plus h. You have your f at x plus h, you have your f at x. Then you can substitute into our derivative definition. You say, okay, f prime at x, my derivative, is the limit as h goes to 0 of what? Of f at x plus h, which is this guy here. Negative x squared minus 2hx minus h squared. Right? This is my f at x plus h, which is this part, minus f of x. What is your f of x? Your f of x is negative x squared, and you close all over h. So it's clear from here. This part is this, which is equal to this part, and this part is this, which is equal to that part. So what we do is, okay, I'm taking my limit, right? So f prime at x is equal to what? It's equal to the limit as h goes to 0 of negative x squared minus 2hx minus h squared. This times that plus x squared, all divided by h. Then on the next step, you group your like terms, so this and that go away. So you're left with a limit as h goes to 0 of negative 2hx minus h squared all over h. So from here, we take out our common factor. What is our common factor? Our common factor is h. So you take h out as a common factor. You're left with f prime at x is equal to the limit as h goes to 0 of h as a common factor. Inside you'll be left with negative 2x minus h over h. And this and that go away. You're left with f prime at x is equal to the limit as h goes to 0 of what? Of minus 2x minus h. That's what we're left with. So once you get here, where you cancel out your h, you can allow your h to approach 0. So what we're going to do, we're going to allow our h to go to 0. So we have f prime and x is equal to minus 2x plus or minus h, which is what? Which is 0. Therefore, f prime and x is equal to minus 2x. So this is the derivative of f with respect to x. Done. So we're going to go to 8.2. We're going to do 8.2 now. Determine the derivative of f at x if it is given that f of x is equal to 4x cubed minus 5x squared. So, you are asked to find the derivative of f, right? If you are given that your f is equal to 4x cubed minus 5x squared. So, when you go to an exam, you are dreaming about something like this. You are hoping that they are giving you something like this. You wish they would give you something like this, because it's the simplest, right? So, we want the derivative of f with respect to x, right? So, f prime and x is equal to, so we just derive straight away because everything is in order there. So, 3 times 4, you have 12 x, then you subtract 1 from its exponent there, so you're left with 2 minus 2 times 5 minus 5, you have minus 10 x raised 1. We're done with this one. That's all it is. You're hoping they give you this one on your exam. Wish they would. So we're done with this one. Go to 8.2.2. Okay, so now we're doing 8.2.2. So 8.2.2, that's determine the derivative of this thing here with respect to x. We want to find the derivative of what is in here with respect to x. So, but you can't just derive this straight away. There are problems here. The first problem is we have a root, a cube root. If you have any nth root, you are not able to derive it grade 12 using the root. Second, you have a denominator. You have a variable that is a denominator, which is x is our variable because we're deriving with respect to x. So we have x as a denominator. So that's not acceptable. Any form of x, any form of variable that is a denominator, it's not allowed for our grade 12 maths. So what we do is, okay, we try to get rid of this and write it as a power. So derivative x, so this is negative 6. To write this as a power, it is raised by 1. So we have x is 1 over 3. That's it. Plus 2 all over x to the power of x raised 4. Done. So we have removed cube root, which is good. Then now we still have the issue of the variable at the bottom. This x raised 4 is still a denominator. That's what's stopping us from deriving at this point, right? So what do we do? We can say, okay, derivative of x of this thing with respect to x. So it's negative 6 x to the power 1 over 3 over x to the power 4, right? Plus 2 raise x over x to the power 4. Okay. So far so good. We still have a variable in the denominator. Must take it up there. So what do we have? So okay, my derivative with respect to x of what? Minus 6 x to the power 1 over 3 times this guy here, x raised 94, right? Plus 2x raised, plus 2 times x raised 94. So this one here will go up, that guy will go up and become those negatives there, right? So what you do, my derivative with respect to x of what? Minus 6 times x. So this times this, the bases are the same. You take one base and add the indexes. So we have 1 over 3 minus 4, right? Plus 2x raised to 4. So far so good. So what do you do? Say, okay, the derivative with respect to x of minus 6x, then you add those two. Say, okay, minus 1 over 3 minus 4. Seems like I don't have my calculator. So 1 over 3 minus 4, 1 over 3 minus 4 is minus 11 over 3, right? Plus 2x raised negative 4. So we have solved that issue that we had of having a cube root. You got rid of the cube root and got rid of the variable that was a denominator. Now we can derive. What we do, the derivative of this is equal to negative, so negative 11 over 3 times negative 6. So I have negative 6 times negative 11 over 3, right? X, then you subtract 1 from that negative 11. So we have minus 14 over 3 plus negative 4 times 2, so we have 2 times negative 4. Then you subtract 1 there, so x raised negative 5, right? So this times this looks like 22, x raised negative 14 over 3, minus this and this is minus 8, x to the minus 5, right? Just to confirm. Okay, still good. Then the derivative with respect to x of our friend, this one here, the original, this negative 6 cube root of x plus 2 all over x to the power 4 is equal to 22 over x over the cube root of x raised 14, right? Minus 8 over x to the power 5. That's it. I hope we did well.